The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. It was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through 2 different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the 2 programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS-HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? And it was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed, and we knew we were getting to the local community, and people were asking questions. So those were the best. I think I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well, and we got to a lot of people we wouldn't have normally gotten.
Aloha everyone, I'm geologist Philip Ong with Mr. Dan DuPont from the nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute, whose mission is to improve disaster preparedness here on the island through education and building our network out. So today is Thursday, August 22nd, today is Thursday, August 29th, 2024. And how are you today, Dane?
Oh, doing pretty good. You know, it kind of feels like a little bit of deja vu with the storms out there coming in, the three of them lined up together. So it seems like every weekend, are we doing a storm dance or not? And
Yeah. Yeah, storm came through last weekend. Yeah, I'm still saying it's last week, apparently. So yeah, it's a little bit of reminiscent there. Yeah, so we've had continued activity on Kilauea, more low-key than the recent weeks, but still some stuff is happening underground following the intrusion we had, and we'll talk about that and what's happening in the volcano. And for our special bonus today, we'll go back to that 1960s era that we began on last week with the two anniversaries that we had. And we'll actually there was a series of 9 eruptions, if you'll recall, in the 1960s, and we did 3 and 7. And so today we'll do 1 and 2, and kind of start off the story and start piecing things together through that era. So that'll be on a back half. Anything else you want to mention before we get going, Dane, with our summary?
Yeah, I mean, it's just interesting to see the parallels with what we have going on now. So we'll go through the update first and then look for the parallels in the second half. We'll do 2 sections of question and answer, one for the current activity in the front and then for the historical at the rear. So go ahead and drop some comments and we'll see what we can do.
Thanks for leading that discussion on chat, Dan, and collecting those questions. And let's get set up and get going here. And I'd just like to welcome back our ASL interpreters also. Good to have you guys back. All right, so yeah, that's the one. And here we go. Hello, everyone. This is our Hawaiian Volcano update for Thursday, August 29th, 2024. Following the second intrusion in 2 months between Pauahi and Maunaulu craters, the volcano has been recharging fairly slowly within this upper east rift area of the volcano, as well as a summit area through here. In the meantime, there's still been inflation in this area of the Middle East rift zone by Makaopuhi crater, which is also affecting Pu'uʻōʻō area, and that seems to be ongoing but has slowed. So just to recall, here is the location of the intrusion that we saw on a satellite radar last week, right through there. And that's what followed the previous month, where we saw first an intrusion back in mid-July, and an inflation migrating to the east, affecting first area by Nepal, and then eventually moving over to the Pu'uʻōʻō area as well. And so that's what we had last month, followed by the intrusion again just last week. And so the question is, are we going to have the same propagation of signals? And it does not seem that we're seeing quite the same speed of propagation, at least so far. But in order to exemplify what's happening here, we can first look at the south flank of the volcano. So here's the summit, here is the upper east rift, this is the middle east rift all through here, marked by the line of craters. And this area just to the south, this is the south flank. And so this area of the volcano moves towards the sea, and that can open pathways and redistribute the pressure where the magma is going underground through here. So if we look, for example, at this station MP3R over here, we can see that its north-south component is moving rapidly to the south still. And these data points are about 1 per day. And so you can see that it's been moving over the last week, sometimes a little slower, but seemingly still going over the last week here. So this is showing that the south flank of the volcano is still moving to accommodate magma migration within this Middle East rift here. However, if you go up to the Pu'uʻōʻō sites, and I think I need to zoom in to show you this station. But if we go to there, we can see that that northward motion that was rising fairly quickly in the last few weeks seems to have stabilized with the data points clustering within the last week here. So that's the slowdown that we see in the Middle East rift. Meanwhile, if we come further, let's come to the tilt meters now. Turn the right ones on here. At Pu'uʻōʻō, we can see that the tilt meter is also stabilized over the last week, with some little influence of the rainfall accumulation from Hurricane Hone that came through the island over last weekend. So stable in the Middle East rift, If we go further up to the actual bend at the escape road tiltmeter, it looks like this map is resetting on me, unfortunately. So let me come back up here and get the escape road tiltmeter. It also is stabilized in the Middle East Rift near the intrusion site from last week, also showing a small effect of the rain from the hurricane coming through. So we keep moving further to the west, and we come to the Sand Hill station by the summit, which is measuring both the Hauʻi area and the main caldera, and the south caldera area as well. And it also is fairly stable, also showing some effects of the rainfall, with an extra adjustment happening in the last couple of days here in the south caldera area, which may relate to some of these earthquakes we actually see nearby in the area still flaring up under this Middle East rift zone. Those earthquakes came back on a couple of days after the onset of the rainfall, and there is a potential link there that it could have been an extra pulse of magma coming through the volcano, but also with the volcano in such a delicate state, continually adjusting from this moving pressure, there could have been some effect of the pore pressure of the water on some of those moving faults and the blocks of rock that might have caused a little bit of extra cracking and migration as well. In either case, it only lasted a couple of days before quieting down here in the last 2 days as we speak. So earthquake counts have been down, but they are distributed in this pattern clustered around the Upper East Rift more densely and more spread out as the slowdown occurs in the Middle East Rift. The south flank still moving is also showing a set of earthquakes shown here. These are colored by depth, so these oranges and yellows are fairly shallow and intermediate, whereas we still have Pahala earthquakes feeding the hotspot from below, plotted in blue here as well. So that's Kilauea's update. Mauna Loa is very quiet. Here are the earthquake rates for the past year, very low earthquake rates per week. The deformation across the caldera has been long-term fairly steady. We are having some data transmission issues and updates on the website, so we haven't seen any immediate effect on the GPS, although we do see a small little bump in a tilt that does not affect the overall long-term pattern of slow recharge and inflation of Mauna Loa volcano. So plotted on a map, here are those few earthquakes adjusting near the summit of Mauna Loa for the last week, and nothing unexpected is happening there. And that's our summary for this week. So we'll move on to some observations on Kilauea. Get some visuals of the East Rift. Let's see where I'm aligned here. This is the Maunaulu camera, looking east towards Kananui-o-Hamo and Makaopuhi. It's underneath this area that we imagine is that large reservoir that is a major storage and transport path along the Middle East Rift zone here. It may be that the magma comes through in a strand more like this and has to fill this area before it shoots over more in that direction in there. I'll show you some of that on the maps a little later. But scrolling back upwards here, let's come to the top. Looking north from Maunaulu, back towards Pauahi Crater, which is in the, looks like in the haze of a passing rainstorm right now, right through here. All quiet on the surface there as well. Here's Pu'uʻōʻō, which when I looked earlier was the one that was actually covered inside of a cloud. But here you see the east side of Pu'uʻōʻō. And really dark shadows looking west from Pu'uʻōʻō towards Kananui-o-Hamo over here as well. So pretty quiet, typical views in the East Rift. You do see the still remnant weather passing through, but nothing major happening out there on the surface or here at the summit where you see a nice rainbow as rain is passing through this area as well. So those are our live views for today. We'll move on to look at the current earthquakes. So here we have the last 2 days of earthquakes looking at Kilauea, as we've been talking about that to start. And you can see the clustering there more so in this Upper East Rift connector area and South Caldera area as well, because you see this one here is a 2.1, 2.1, and those are the largest ones in this area. There have been some closer to magnitude 3 right in this zone right through here. I see 2.4, magnitude 2 right there as well. And recently, much slower on the Middle East Rift as far as earthquakes flaring up. So that's the last 2 days. If I put the last 2 weeks, you see the comparison there. where we had that big south flank event, the 4.7 right here. That was a big indicator of the flank moving out of the way, as it continues to do still today. Let me zoom it out. So here's the last 2 weeks, a lot of Pahala earthquakes. Mauna Loa's east flank seems to have some adjustments. And there are some interesting offshore earthquakes off over here as well in the magnitude 3 to 4 range that are also adjustments at the flank of Mauna Loa in the other direction. Settling earthquakes elsewhere around the island and some shallow ones as well. Here's a magnitude 3 that was offshore Hamakua. But back to the last 2 days, you see that most of the action is here in the south part of the island, as expected. So looking at the earthquakes plotted by time now, so newest ones first, the most recent ones are down here by Pahala, which has had some deep earthquakes happening today. But there's also been a 2.3 out here, just south of Pu'uʻōʻō area, showing a continued south flank movement as the magma is trying to build pressure right in there. So let's sift this for the largest ones. There is a 3.1 that occurred, and this was about a week ago. 3.1 or 3.0 occurred a couple of days ago, 3 days ago. Then we have the deeper ones happening beyond that, down through here, right, and further back in time. So that's the layout of the earthquakes. Go back just to the 1 day, and you can once again see that smaller cluster there. So moving on from our earthquakes to our monitoring signals, I thought I would just share the USGS updates a little bit and just point out something that we haven't always seen in the past. So today's update, to start us off, shows Kilauea is not erupting. There's no significant activity in the lower east rift or southwest rift. And activity is still elevated as far as earthquakes in the upper east rift zone. The prognosis is still that changes can occur quickly, as can a potential for eruption. But right now, imminently, there are no signs of eruption. We have earthquake counts noted here. We have our most recent gas measurement of 75 tons per day of sulfur dioxide, measured about a week ago. That's below that background rate, but can still be concerning. We'll pull up our VOG forecast in a few minutes here. But overall, there are no significant changes on an east rift. A gradual inflationary trend continues to be seen on GPS instruments around the summit. And otherwise, things are moving pretty quietly as far as their updates. What I wanted to do is, scrolling back in time, just note the effect of the hurricane, because this is not something we've seen very often in the past, but I can go back past Wednesday to as recently as Tuesday was the last day they were noting effects of, for example here, changes in the Uēkahuna and Sand Hill tiltmeter overnight appear to be due to ongoing heavy rainfall, but remain stable otherwise. So they're putting in a warning here about this rainfall effect on the tilt signal. Uēkahuna and Sand Hill noted at the summit, but also here in the rift zone, we're seeing changes in the POC tiltmeter appear to be due to ongoing heavy rainfall, but otherwise remain stable. So same standard language there, but noting that 3 stations on the tiltmeters are being affected by the rain. So that is interesting. That's all I'll spend the time on our updates here, our USGS text updates, and instead I'll come to the data. And the data is showing some interesting things as well, as far as the stream at least. So here we have, let's see if I can get this to refresh a little bit. So here we have the last 2 days at Uēkahuna, showing we had a range of a couple of microradians of changing over that time. That began with inflation, and we'll have maybe a deflation-inflation cycle, although we're still a little bit coming off the back end of that storm, and I do wonder about some lingering effects. And so some combination of the very tail end of effects of the storm with inflation of the volcano happening here, maybe a little deflation-inflation cycle, something like that happening in the more near term. So that's what we see right here in the last couple of days. But if we go back, the actual rainstorm was from the 25th through the 26th, really. That's kind of this period right through here. So what you can kind of see is this longer term background rate of inflation coming up here. It seems to continue, and maybe this little ramp up right there, might be the most noticeable effect of this storm. And maybe a little bit of the stuff through here also, right? Maybe it's a little bit extra bulged up right through here. Maybe you would have had more of a something like that, right? But hard to really know exactly. So very small effect in the grand scheme of things. Overall, we're still showing inflation at the summit of the volcano. And it does appear that on these graphs that for a long time have tried to compare the relation of pressure at the summit with pressure at the Middle East Rift, in particular at Pu'uʻōʻō. It looks like we've now had an effort to reestablish the Pu'uʻōʻō tiltmeter signal, and it is now showing back up as a green line on here. And it's popped up here today, and it corrected the errors, filtered out some of that calibration data all through here. And we'll see if this, once again, shows this linking pattern from the summit to the rift. Because what we used to see in the past was we'd see a deflation inflation event at the summit, and after a period of, it would vary sometimes as quickly as 2 hours, sometimes it would be as long as a day, you would see a deflation inflation event corresponding at the rift zone, showing the connection of magma from the summit to the rift. So that is why this is interesting and why we'll watch this in the future, because you could imagine that if we have a good connection, that tells us where the risks are for an eruption. And if we don't have a good connection, that tells us that uprift is where the magma will likely build pressure to try to break through, whether it's underground or above ground. So nice to have the Pu'uʻōʻō signal back. Welcome back, Pu'uʻōʻō. And otherwise, just Uēkahuna signal by itself looks like this. So put this in here for backup in case the calibration was still happening. At Kīlauea, 25th to the 26th is our main window. They're noting effects maybe through the 27th. And maybe you can see that here, right? This seems to be a big effect from the rain right there. And maybe it's still rounding off until somewhere in here on the 27th as well. So there is an example of a possible effect of the rainfall on Kīlauea. Not quite as obvious at the Sand Hill, but once again, our scale is much more massive there. So it could just be that we're moving the ground a lot, but not as much as the ground is still moving from the magma. The whole thing is pumping up, as we heard Dr. Ken Han state in his update last week. Like the whole thing basically deflated, and now the whole thing is pumping back up all the different parts of the magma reservoir that are all connected in. Southwest Rift, Summit, Southeast Rift, all different little pockets are all getting pumped back up and refilling with as much magma as possible. And that's how you build enough pressure within the whole system to then propagate cracks and magma further down a rift or out of the ground for an eruption. So we're still in that process of refilling all that space and waiting to see where and when it catches and where the pressure manifests and what comes next. It's an interesting story. So there's that Sand Hill station. We noted that little jump from the earthquake nearby as well with the rain signal. On the escape road, still that long-term following the most recent intrusion signal here. Long-term kind of deflation seems to be apparent. And you see how the rain signal manifests differently on the different components, but still there is an effect there. Yeah, Pu'uʻōʻō, there it is again, that little bump right in there is likely that little rain effect. And so what's interesting is that we were looking at these signals at Pu'uʻōʻō with this green line looking down a rift towards Makaopuhi, so swelling from the side, and this blue line showing more towards the rift zone itself. So we're looking for, if we see this line eventually start going upwards in a significant fashion, that would be one possible clue of magma reaching this area south of the station by Pu'uʻōʻō, which would be what you'd expect the next barrier to be overcome by this pressure of magma in the East Rift. Right, so I'm not sure if it will overcome that barrier going to the east, or whether it comes up to erupt, but long term, it's trying to refill the entire thing back to where it was before. So, interesting to note that over here on this right side of this graph, this is becoming a little flatter than it was. Right, it's not quite showing this decrease that it was showing quite so recently. So we'll keep an eye on this as a key indicator signal of what comes next with this Middle East Rift magma migration. Further down at the Jonica station, we don't see any of that effect. A little bit of rain, but it's really blown out in the scale because the scale is really shook up by this jolt of an earthquake that occurred earlier last week. So not really much to see there. And that's our tilt signals to look at. So to try to pull it together, let's wrap it or compare it against the earthquakes. And so there are 2 days of higher earthquakes. As I mentioned, it was the 25th and 26th, so it was really right in here is the onset of the rain. Right, so there's a little bit of a delay to the start of these earthquakes. So not quite clear if that's the effect. And just to be clear, and I'm not, there's no conclusive evidence to say one way or the other. I was just kind of putting out what the possible effects of water are on these kind of faults, right? The one famous experiment with geologists was, how can you get a glass of beer to slide across the bar counter, right? And it's hard to do that if the counter is dry, and it really comes down to that glass of beer being sweaty and having that layer of water and underneath it. That creates a little bit of pore pressure that reduces the friction between the glass and the counter, and that allows the thing to move. And that's very much how faults behave. You can actually have pore pressure going in, water going into that pore pressure in a crack, for example, pressurizing it, releasing the friction from the sides and allowing faults that are under pressure to move. That's one way they can actually affect the ground. The other is that the rock strength itself can be affected by pore pressure, and you can actually create new cracks in the rock by changing the distribution of pressure within the rock too. So you can both create new cracks, and you can cause old cracks and fault lines to move as well with pore pressure. This is not a huge major effect. It's not like this is causing a giant eruption or anything like that. But these little adjustments of small increases in earthquakes and small adjustments in the ground is what I would expect if you were to have an effect of water, right? Something fairly minor, not cataclysmic or not setting off a giant 2018 kind of situation. This is what you actually would expect. But it could be, it's just as likely that it was a pulse of magma refilling the East Rift, as we've seen this whole progression over the last 2 months. Be one pulse, another pulse, and it fills a little more slowly, then it migrates through a bunch of earthquakes, and it's all coming in pulses every single time. So it could just be the newest pulse as well. That's just coincident in time. In any case, it lasted a couple of days, and that was the end of that. So we're back down to this lower threshold yesterday and today. Looking at the depth versus time on the earthquakes, we can just reassure ourselves that those earthquake counts are coming in this shallow band in the Middle East Rift, right? Those are our 2 days right there that are showing the high counts, and those correspond beautifully to this band of earthquakes here, which in detail you can see actually starts before the flip of the day, right? If we're comparing the onset of rain, but really accelerates more so the next day right in here. And you see it slow down, and we actually had another little brief burst that didn't add up too many counts happening overnight. We reviewed the map earlier in our summary, but there it is once again. And in cross-section, we do have this interesting cluster of plotted in purple deep earthquakes, a little bit deeper than usual, down around 25 miles away, straight down, and they're offshore over here. So I'm not clear if this is just settling of the island or one of those roots of the magma pathways that feeds from this area deep and shallow, getting shallower and shallower through here. You see some blue dots in here also. That could be possible part of the pathway, but in any case, this is a long way away from the surface here, 25 miles down. All right, looking at the last month, here we can more clearly see the pattern of long-term inflation of Kilauea summit, with that possible rain effect being contained to just this little area right in here, and here coming into it our East Rift Zone signal. Coming down, we've looked at the tilt across all the volcano already, so let's move on. Show you the earthquake counts per month. Not nearly as many as we had during that intrusion last week. And there is a little cycle compared to the previous little cycles we were having. You can see there's those cycling pulses that I've been describing expressed in the earthquake counts. In earthquakes per week, here we are, we ramp back up, but we seem to be oscillating up and down with those pulses, and depending on how they fall on a week break right here. And overall, we're still the highest earthquakes per month that we had last month in the last 5 years of Kilauea counts. This month looks a little bit more subdued since that intrusion was a little shorter lived than the one we had back in July that lasted 3 days. Ours only lasted 1 day here in August. And that might be most of the difference, but still fairly high counts. What we're seeing this month as we approach the end of August here is still higher than most of the last of the 5 years that we saw in Kilauea here. So we looked at GPS on a map. I can just point out some of the patterns across some of the other stations. So let me come to the top here. All the caldera stations are a little bit short on data in the most recent days here, likely because the storm is still affecting data transmission and updates on the website. So we don't exactly know the details apart from the USGS still reporting that volcano continues to inflate according to GPS stations across the summit. So the pattern must be continuing here, right? This overall uplift, and stations moving in the directions that they move. In the northwest, it moves northwest. In the southeast, it moves southeast. They all move away from the center of swelling of the volcano, but they're all moving upwards, which is this bottom panel right here, which I'm pointing out. And sometimes a little slower, but all moving upwards and still bulging as the summit is accommodating more and more magma over time as it's pumping up with the rest of the system here. Further out, still swelling a mile and a half away at these two stations. And coming to the Upper East Rift, we're seeing this area that was the location of the two intrusions with offsets here. Seems to be not really rising too fast, but maybe is still rising as well a little bit there at the end. Keep moving. Maunaulu is becoming more clear. This is a station that's very, very noisy. But now that we can see through the noise a little bit, we can see there's some clear offset and that the ground dropped down at Maunaulu, in fact, as well as shifting to the south and to the west over here. Right? That's what those averages are now telling us with a little more confidence that that is an area being affected by the intrusions with the ground dropping as the magma is moving away further to the east to feed that Middle East Rift intrusion. So here, this is the pattern of those Middle East Rift earthquakes, GPS stations, I'm sorry, that have stabilized their movement. All these are kind of coming up and hooking and flattening out here at the right. Right, this is a northward movement, a little bit more so an upward movement as well. Yohamo, 7 miles east. At Napau, 10 miles east, same pattern there. Right there. Kamoamoa, similar. Now these appear to still be moving a little bit. So it's hard to say that it's stopped entirely, but it does appear to have slowed down here. Okita is very noisy in the recent months, so we'll just ignore those data points. But here, Pu'uʻōʻō, once again, same pattern. Jacuzzi, same pattern. And Jacuzzi is also showing a little bit interesting data here, but since there's only one data point and it's showing so far off the trend on every one of these components, that is likely one that will be corrected, and we'll wait to see what the error ends up being with that, and likely some noise from the storm there too. So further east of Pu'uʻōʻō, this is a suspiciously looking maybe northward movement that could affect that, show that that bulging effect of Makaopuhi zone has reached as far out as this station, RKAR, but perhaps it's something else. We have to wait for more data, and similarly, we're looking even further east, 17 miles east at this R931 site to see how fast or if the magma reaches this station with its influence as well. So that's the rift zone itself. There's a lot of stations on here. Further on at Jonica, no signals, and down at NANT, also no effect visible in the most recent weeks here. These are 2-year plots, so that's really what's relevant. The rest of it's showing the history over the last 2 years. The flank we noticed was moving quite a bit too. Both pulses of intrusion have led to accelerations of the south flank movement. So this station here is the GOPM at Idaho, and north-south component here in the middle really shot down a month ago with that intrusion, and you can see a smaller drop down, but still moving and more stabilized here at the right end of it. So that's the pattern we see on a south flank. At some of these stations that are more central, like Idaho and Mulivaiopele also. Makaopuhi didn't quite show that clear two-stepped, but it's still moving to the south there, and it seems to be moving a little more slowly as those data points are clustering, both in the up and down and in the north-south here. Kalapana Trail is one of the two that really appears to be still moving pretty fast. A couple of data points clustered on themselves right through here, but they're still stepping down every couple of days, continuing that downward trend, right? So this is the last 2 years once again, so you can see how in the last 2 years this station has been just trying to wiggle its way to the north a little bit, and within the last 2 months has really shot to the south. let's see how far here, right? Where that looks like. We'll call it close to 0, and we'll call that close to, let's say, 11, right? So 11 centimeters. Let's move there. Maybe what's that, 3 or 4 inches or so in the last couple months. Like the whole stack of rocks of the volcano pushed 3 or 4 inches sideways by the pressure of the magma building in the rift zone a few miles away over the last 2 months. So fascinating to see these movements here. And of course, opening some concerns as well, but this is always a long progression. So we'll keep watching it and informing as it develops. Hauʻi still moving south pretty fast there, but the MP3R south of Pu'uʻōʻō is one of the more clearly moving stations. You can see here, still trucking along to the south. At the coast, it's not so obvious as we saw before. At kind of point, we had noticed an effect of the previous intrusion, not so clear here today. So not as big effect this last week as it was the previous month. The Southwest Rift is still not taking magma in by the looks of it. It's still just stabilizing following the intrusion and eruptions of late. And the southwest flank is also not seeing that same effect, just seeming to be moving south at its regular pace as it has been in recent months. So that's all of the monitoring data there. We don't have any new satellite data to share. We'll hopefully come around to that next week. So before we wrap up Kilauea here, we'll check in with our largest hazard, which is still the gas. And courtesy of VMAP, the Log Measurement and Prediction Project from University of Hawaii at Manoa, we'll share the forecast here. So here it is, showing emission site at Kīlauea volcano. They're still putting out 311 tons per day, which is on the high end of it. We saw the report from USGS at 75. But we're still seeing where the wind is blowing this gas around the island. So mostly still to the south, Mauka areas, above Pahala, towards Ocean View, above Nalehu as well. Sometimes wrapping around Kona Mauka or into the saddle as well. Or when the winds are shifting, you can see here, it starts off up back towards the saddle and Hilo, in fact, as well. So, but with all the rain and the weather, probably not a whole lot of people noticing that. But if you do, that's probably why winds are a little funny with the passing storms. In a national park, everything is in the green and has been in the green, as you can see from their history on the charts here. Just to make sure we check in with our Citizen Science Monitoring Network. I like to see it when it's looking clean as well, after a nice big atmospheric cleanse with the rainstorm. And there you see what it looks like, everyone in the green, maybe one in Kona here. Seems to be one station that's always showing a little bit high. Maybe it's next to some exhaust of something. So that's our air quality report for this week. And this week I will put in our community corner right in here, just because it is more relevant to this section, because we've had in the national park, we had the Trinity Craters Road be closed due to the cracking. That has since reopened yesterday. So Trinity Craters Road and other previously closed roads are now open. That includes the areas accessed by the Trinity Craters Road, like Hilanapali Road and a campground and backcountry sites as well. So that was one closure that we had announced last week. And there was also a backcountry closure that occurred over the weekend because of the tropical storm force wind warning. So everything's open once again, though, as far as the Trinity Craters Road and backcountry sites. What is not open is the construction areas up around the summit, most significantly developing as early as September, which is right around the corner from us, a few days away here. We expect the visitor center and restrooms, lanai, and parking to be relocated to the Kilauea military camp, portable facility. So keep your eye out for that if you're in the area. And that is the community corner for this week. And with that, I'll take a break here. We have coming up on the other half. We'll go into the first of the 60s, checking Volcano Watch, Mauna Loa, and more as well. But to you, Dane.
Yeah, and we'll get to your questions. But first, I'd like to thank everybody for tuning in today. We rely on viewers like you to like, share, subscribe, show up, the views. Everything helps get this information out there further through the algorithms that everybody hears about nowadays. But it does help. It really does. So we appreciate you there. We also like to thank the Puna Strong and Kilauea Recovery Grants through the County of Hawaii and Hawaii Community Foundation. They help make this type of content as well as our other projects possible. And they really do give us a bunch of support. So we appreciate them. And with that, I think I'd like to bring on Lou, Two Pineapples, help us out. Lou, Phil will be right back. And yeah, let's get Lou in here. Hey, Lou, how you doing?
I'm good. How are you doing tonight?
All right. So, yeah, we got some supporters coming through and making donations. Again, the best way to support us is through hveri.org/donate. You can see it on the screen now.
There you go.
And that is where we take donations. We also take super chats on YouTube, but we get more of the proceeds through the website. And plus, we have a record to give you for tax deductible donations. So definitely, that's where we encourage people. Lou?
Yeah, hveri.org/donate. We have a couple options on there as well. So one-time donation. You can also do a monthly donation on there, which is also very helpful in case you forget. hveri.org/donate. And we are also, the door's always open for any type of corporate business sponsorship. So go ahead and reach out to us. You can get to our website, hveri.org, and hit the contact button in there to find out stuff. I think that's all I have on there. hveri.org/donate. Hit that page. Yep, that's what I got for you, Dane.
All right, sounds good. I appreciate it. Thanks for stopping by, and I'm glad you were able to weather the storm over the weekend.
Yes. Not too bad this time around.
All right. Thank you, Lou.
You're welcome.
There we go. Now we're in the right spot. All right. So, yeah, we do have a couple questions if you want to talk about those.
Sure.
Yeah, so let's go ahead. Oh, shoot. Sorry. I wanted to try and roll our question and answer thing, but I don't think I have it loaded. All right. So we can just sit here for now until you want to show something. Anyways, so 2 questions we got lined up for you. First one is from Victoria. Add to it a little bit, but so magma is on the move everywhere, including Pu'uʻōʻō, or because it's kind of a broad area that we're talking about. Are we talking specific? Is it a very broad area that's in that has magma intruding under it, or is it one area that's influencing everywhere else?
Yes, it's a good question. It's on a move many places that it could be, but Pu'uʻōʻō is not one of them quite yet, is the answer, the short answer here. This graph maybe shows it, this map shows it the best. Word inflation center is over here just to the side of Pu'uʻōʻō. And so Pu'uʻōʻō is swelling, but it's swelling being pushed from the side to the northeast. So both sides of the rift zone, north and south, are both moving together away from this swelling that's to the west of there. Right. So this is an area under Nepal. There's an area near Makaopuhi as well. So these are all storage areas that are known along this segment of the Middle East Rift, and they're all active now. Whereas before we were only activating this Upper East Rift segment, maybe some stuff happening here in a Kauai fault zone, the South Cloud area all through here, and off this map, but also in the story is the Southwest Rift, which has also been taking inflation as well. So magma was in a move earlier in the Southwest Rift and the South Caldera area, kind of through there. And now we see this image from, was it a week and a half ago now or so, showing inflation was happening at the Summit South Caldera and at the Middle East Rift. And we'll wait for the one that happens next week, but I would imagine that we're going to see more of it happening in here, and this will be a smaller signal, at least with this particular snapshot, because we're looking at frame by frame in slow motion of this evolving movie of the volcano that has changes over the course of weeks and months. So sometimes it happens really fast with the earthquakes, but when it's moving and adjusting big blocks of rock, it can take days to weeks to longer to propagate. So the last we saw, it's still over here, and that's why I'm looking at those signals on Pu'uʻōʻō itself to see, am I seeing them moving apart? If they were doing this, then I might believe that magma went in between there, right? And if they're going like this together, then it's something from the side pushing them both together. And that's where we are presently.
All right. We have one more question here. This one is from Yvonne, who asks, the wind can also create noise at a GPS station, I guess. Maunaulu is always extremely windy, so I would not be surprised if this creates some of the noise. Do you have any insight on that?
Yeah, it's a good point about it. I think that's really the same as far as I could take it myself as well. So I mean, it does seem like there are other stations that are windy also, but somehow they're able to average them. I'm not sure how they do that. I'm not an expert in that at all. I'd love to ask someone like maybe Ingrid Johansson about that. Right? How are they filtering or cleaning GPS signals in different places? But I really don't know the answer to that. Yeah.
Right.
Yeah.
I know we've talked about tilts before and the influence on them, but not as much GPS, maybe.
Yeah, I mean, that seems likely, right? Because that area, it's not like there's a lot of tree cover near the station or anything like that. It could be that it's on a loose block of rock. Maunaulu is a lava shield. It's got all these different chunks of its sides, right? Because it went through growth, collapse, all this different stuff, and maybe it's like near a crack or something, and that piece of land is just actually moving. That's another possibility, but wind is likely too. Yeah.
Yeah. All right. That gets us through the questions for the first segment. If you guys got any more when we go back and study the history a little bit, take a look at it, that'll come a little bit later. But I think that gets us through the first segment.
All right. Sounds good. I'm hearing like a little interruption in my sound. I think it might just be my earphones. Unless you guys didn't hear anything, are you? If you do, let me know. All right, so let's move on then to our volcano awareness presentation, which, just to recap, this is a table of eruptions on Kilauea. And I know this is a lot of text on here, but if we focus on this column on the left of the eruption years, what we're focused on today is going to be this series of 1961 and 1962 eruptions right here. And really, this is part of this whole sequence of the Middle East Rift eruptions, which really begins not at the start of 61, but in September here, and goes through much of the following decade. There's two more on this next page, February 69 and October 68. And I got to cross off this one in here, which is 9 months of summit eruption in the middle of this decade. So apart from that summit eruption and these 3 summit eruptions that begin this sequence, we have 9 eruptions in this Middle East Rift area in the 1960s. And that's an interesting era to examine, because there are some parallels to what we see today, and maybe tells us what the range of possibilities might be for the activity we're seeing today as well. So in more detail here, let's see if I can get this a little more zoomed in. We had the 1960 eruption down in Kapoho, and following that eruption is what we're picking up here. February 1961, March of 61, and July of 61 are summit eruptions. 1 day, 3 weeks, and 1 week, all at the summit. And that's followed by a 2-day eruption in September 61. That is this first number 1 of our sequence of 9 of that eruption. And it gets as far as the Lower East Rift as it's actually categorized. And we'll show you exactly where. It's not all the way that 1960 or 2018 got. This is, in fact, the famous Jonica flow where the station we check all the time is from this eruption, in fact. So that's about where it's coming in. So let's look at the famous paper that described this eruption. This is professional paper 474D from the USGS. So this is by Don Richter, Alt, Eaton, and Moore. And they're grouping all the 61 eruptions together in this account here. So I will jump down and maybe read a little bit of the abstract so you can recap what actually happened during this era. And I'll summarize some parts and read some other parts here as well. So try to keep it flowing for you guys here. So the 61 eruption, all 4 eruptions, as we'd call them today, came between February and September. 3 summit eruptions with a flank phase. In this era, they called inflation tumescence. So if you see this word in here, that's what they're talking about. Think of it as just inflation. Inflation began in the summer of 1960 following the Kapoho eruption and did not change throughout the 3 summit eruptions until the actual East Rift eruption occurred. It was preceded by large earthquakes and strong harmonic tremor about 16 hours ahead of the eruption in September of 61. The 3 summit eruptions were all contained within the collapse pit of Halemaumau. I'll just leave it at that for now. Whereas in the flank eruption, the fissures opened up along a 14-mile length, and it went from around Napau area all the way down to the Jonica area. Of those, a total volume was about 2 million cubic yards, with a lot of that lava draining back into cracks with no large flows formed in that eruption. By the time we actually get out there, a lot of these areas are just fuming and steaming cracks in the middle of very dense jungle at the time. So that's the summary of that eruption. I won't go into any more of that recap than that, but I will instead go forward to just show this is how the pit of Halemaumau looked following the collapse and subsidence of 1960. So there is that pit of Halemaumau is this entire outside darker line in through here. And within it, we have 3 collapse pits, one in the center right through here, one in the southwest, which is actually within this larger basin, and then a little bit off, kind of embedded within the northeast wall, there's the northeast collapse pit as well here. So you see this line A to the middle with a slight bend to A prime. That's the line that we have this profile along here showing how within the crater you had a smaller collapse pit, another collapse pit, another collapse pit, and then there's the outer edge of the crater right there. So all this is detail within the middle of it. And I'll just show this to you because I'm going to show you the pictures as I scroll through here. I'm not going to go into too much of the detail of the science of those summit eruptions. Rather, I just want to show you what pictures actually exist and what maps exist. So here's a map of the first 2 eruptions that occur in February and in March, and the difference being the filled in symbols A, B, C, D, E. I'm sorry, A, B, C, and D. Those are the February eruption. So you can see there, this is all within the northeast pit. So there's a northeast pit, there's a rim of Halemaumau, and here's the main basin off to the side. The center would be off that way. So within the northeast pit is where these first 2 eruptions happened. The first one right through there, the second one within that little pit within it as well, there and there. Didn't cover a whole lot of area, and it looked something like this. Well, it doesn't look too different from the 2008 era to my eye, when we saw that collapse pit with lava lake within Halemaumau as well. And there's one view of it. And there's another view. In the collapse pit, there's some lava flows bubbling up here, right through there. I'll keep going. They have a lot of sequences of photographs here, so different points in time, different hours of the day, because that was one of the ways to document things, since we weren't shooting time lapses at the time. There's one of the vents glowing, putting out fume. And looking at the horizon here, there's a rim of Halemaumau and the edge of Kilauea caldera off on the horizon off over there as well. So here you can see further in all the steaming area, collapse pit in the middle there, collapse pit over here in the northeast as well, where all this action is actually happening. Okay, so the third eruption, the one that happens in July, occurs in the main crater. So we had March and February occurring in the northeast pit, and then we actually have from the western pit a lot of lava flows that come out and start filling this whole crater eventually. So you see here A, B, C, D, lava river coming down into the pit. And that's the orientation for this July eruption. So there's a nighttime view, fountains, lava river feeding into the lower pit, feeding the crater there. More in a daytime view, river of lava filling the crater off to the side, going around some of that inner topography. Once again there. And a sequence of maps as well, showing, look at this outer outline, how much the lava lake is actually filling. It's filled in that entire lower pit, and it's going to spread all the way to the walls. And there's a little lava spray, some fountaining happening. River of lava coming off that way there. See all this cinder piling up against the downwind side. New map with lava all the way to the edge. Fountaining fitting the lava lake. Lava burying everything in the crater. And then finally, the eruption ends and the lava surface subsides, and you start seeing lots of little islands and a pockmarked surface on Kīlauea summit. A little cartoon of how that piled into that crater there. But our focus really here is on the rift eruption. So I'll scroll past these piles of cinder that they found at the summit and move on to this rift phase. So the rift phase, here we have one of the first images. And what's happening here is chronology in September of what's actually happening. So September 20th to the 28th here. This whole event lasts, as we saw, it was really 2 days of eruption, but maybe about a week of effects on the volcano. So at the very top here, harmonic tremor and different stations. So harmonic tremor was actually detected back on the 21st. So we're likely having an intrusion occurring beginning back here. And only after those 16 hours of tremor do we have the first eruption with a little bit of lava erupted in that first pulse. There's a second pulse that puts out more lava, and a third pulse that puts out barely any at the end there. And there's your 3 days of eruptions. At the same time, this is inflation, or in this case, deflation. The summit is deflating as magma is draining and feeding the East Rift eruption, similar to what we've seen recently. And we've seen fault scarps grow. And in this particular case, at Jonica, there's a delayed effect. So you see here on the 23rd, right, following this big pulse of magma coming in and erupting out, that's when you start seeing this extensive fault movement down rift, which is really impressive when you look at the pictures coming up here. So that's more or less the sequence of it. Let me zoom it back out here, and I will not go through all those numbers with you guys, but there is an aerial view. Pull it out a little more. An aerial view towards the southwest from above Kīlauea crater, showing the upper part of the Middle East rift zone. So that's Kananui Hmau right there, with Makaopuhi crater just to the side. Nepal crater is right in here. So you can see west of Nepal is the westernmost crack and fissure and fume, but sporadically, as you move further towards the east, you also step to the south. So east and south, moving on. Here's that whole sequence of cracks. And in case this looks kind of familiar, but a little weird to you guys, this is where Pu'uʻōʻō now stand today. And so it looks completely different. All this forest here is all pre-Pu'uʻōʻō days back in the 60s. So that's the image there. Here's a map. And so they've actually written in these dates, which date, September 22nd of September, there, and there, small fissures. On the 23rd, there, and there. And on the 24th, you got a little one right in between them right there. Right, so down right through here, Heiheahulu is a lava shield that's covered in forest. If you look at more or less where was the farthest up rift eruption of the 55 flow, was more or less in here, where the quarries are along the highway down there. It's north of that was the farthest east reach of this eruption, right? But what's interesting is we're actually along the northern strand of the rift zone here, as opposed to the southern strand, which was the one activated for 55 and later, right? So interesting. This seems to be the connection it comes across. But as we noted, these series of cracks have the stepping effect where they really have to go to the south as they move to the east across the rift zone there. Okay, so let's see there. And another image here. I'm going to zoom it back out. At the Heiheahulu flow, the big fountains and some flows being fed there along that margin. So, all right, that's the images that we have. There's a couple of things I wanted to point out from the actual chronology of it. So let me find where this begins here, because there's some interesting things to note here. All right. So coming back to, where are we? All the way here, the flank phase. So just to highlight the points, the tremor began around Napao, east of the summit, and then through the afternoon, everyone was feeling earthquakes around the national park before the lava actually breaks out. Right? So people are feeling this for many hours ahead of time. They're all looking around there. They see the tiltmeter start to deflate at the summit, and they're looking around to see what actually is going to happen, looking across the landscape. Where is it going? Is it going to pop out? If it pops out, where is it going to pop out? So before sunrise on the 23rd, glows in the east was seen by tourists at the Volcano House Hotel, and the strong smell of wood smoke, at times mixed with a slight odor of sulfur dioxide, pervaded the summit area. Unfortunately, however, most of the summit region and east rift zone was covered by a low, heavy cloud bank. By 6:45 in the morning, clouds had dissipated over the area south of the summit, and a hazy band of volcanic fume, brownish gray, extending southwestward for almost 15 miles was revealed. So they go and try to find in the middle of this cloud where the eruption actually is, or like walking around sniffing the air. They climb Pu'uʻōʻō by Maunaulu, and they note that even though visibility was less than a 1/4 mile, the wood smoke and the gases were strong enough to cause eye irritation right there. So they knew they were close. They just couldn't see exactly where and how to get there and how to get there safely and to stay safe once they were there. They note that there were other reports of glow over the rift zone coming in, earliest at 4:30 in the morning. And at 8 o'clock in the morning, a pilot on a regular tourist flight saw lava fountains through a break in the clouds near Kīlauea crater, that close to the down rift area out through there. So they actually collaborate with the National Guard to have their flights during that era. So they fly over to figure out where all the flows are. While by foot, they approach the westernmost of the stinging fissures between Napao and get there by 2 p.m. that same day. They note heat, fume, dead vegetation on either side of the crack. And they also note that the most active part of the rift was in nearly impenetrable rainforest. So only the westernmost flow of that phase was actually examined. And then they use aerial reconnaissance and photography to map the rest of the flow and estimate the volume. So in the end, it's not a whole lot of volume that goes through there. But because it came out hot and fast, it appears that the lava flowed quickly through several groups of trees and formed lots of lava trees in this area. So they actually write a paper at the time noting the lava trees in the area as well, which maybe were not as well documented up to that point. So then they note tremor moving further over, closer to Pahoa. And notably, this is not noted anywhere else except in this text here, they have a large, shallow earthquake near Kalapana, 6 miles southeast of the crater, rocked the entire island. So felt island-wide, this must have been a south flank earthquake opening the rift in that area, right? So this is not too far off of what happened in 2018 when South Flank earthquake opened the area and allowed a further pathway towards the Lower East Rift. But that's what they all felt, and from that point, it was pretty clear that they were going to see something further on. So the next day, 10 in the morning, a series of audible explosions heralded the resumption of activity along a discontinuous series of rifts that was 2.5 miles long. And that was 5 miles offset to the east from the previous day. It didn't last long. although the fountains began small and eventually grew to heights of 300 to 400 feet. At 12:30, Civil Defense Agency orders evacuation of towns along the seacoast south of Pahoa. However, shortly afterwards, they note most of the lava pours back into a large sump-like crack several hundred feet southeast of the eruptive rift, and it swallows all the lava and no extensive flow results. So interesting, they actually evacuate some of the towns along the coast, but a giant crack swallows all the lava and there ends up being no big effect. So the fact that there's no big flow is not because there was not a lot of lava coming out, it's because it all went in a crack rather than going towards the ocean. So they note that the fountaining ceases around that time, everything goes quiet, but following that, they note the 6 flows, and then they start noticing the movement of the ground along the faults. So let me see here where we have the faults. There, I mean, they do note lava trees, really impressive. Here they note some 14 feet high. There's somewhere else they note one 21 feet high. And those were a notable feature of that Jonica flow for some time until they all got shook down and knocked over there. So the final pulse was on the 24th of September, where small group of fountains from a 500-foot fissure 1 mile northeast, less than 50 feet high, and go back into the vents, right? So you can imagine how we might behave if we had 3 different days of eruptions. One day is all in one area. The next day it's 5 miles down rift. The next day it's jumping back up the rift. Those are kind of things that are all possible, but it just shows how you really can't jump to conclusions with activity on this Middle East rift. It really can bounce around a lot, and it's really just watch and wait and see and respond accordingly. So it was all over by the 25th. Minor displacement on faults at the east end continued at a decreasing rate for a few days, and great amounts of steam and fume boiled from the vents for at least 2 weeks. They note that the summit was drained of about 70 million cubic yards of magma, which is much more than around the 2 that they saw come out. So really they're talking about this is a big intrusion that occurs, and it leaks out in a few places as it's moving its way into the Middle East rift there. Just to show you guys how these faults are moving, let me come to that area of the photographs here. We've come past those tall fountains. And here, for example. So here is September 24th, which is the second day. They're showing 7 feet of displacement on this crack where these guys are standing. There used to be a Jeep road across here, so they can tell exactly how much it offset. 7 feet on that first day. That's a good amount, but let me show you 2 days later. This guy's all the way down here. Look at the other guy all the way up here. By this point, he is now 10 feet below the other one. And so those faults are really moving quite a lot. And one more image of that area of crack. This here, there's a person right there. You can see them. Right? See these vines stretched, like the plant was actually growing across this land and the ground moved and the vine is stretched across this big movement of the earth, which they're noting south-facing scarp about 20 feet high between the Heheahulu and Karamuki flows. So massive ground movement. This is showing how much of the magma was filling underground of this area and pushing the ground upwards with these big fault lines. So that's really the 61 eruption. We'll move on to the 62 eruption, which was, well, actually one more note on the 61, this very short paper by Jim Moore and Don Richter about lava tree molds. Just to show you guys, in this map, the north is that way. Here's the fissure. The lava goes into this area between some cracks, this little valley, and flows out through there, through the forest. There it is, like a flash flood through the forest. And that's what leaves behind a bunch of lava trees. Right there they show the trees growing in the valley, the lava filling the valley, coating them. And afterwards you have some dead tops of trees, burned tops of trees, and encased trees wherever the lava was deep enough to bury them. And they looked like this. And I know these are really bad contrast images here, but this is the 61 eruption paper. There they are. A few images and one more of these pages of tree molds that are nowadays look like a lot of the other ones we've seen, but at the time was something that they thought was quite noteworthy to document. Nice U.S. government issued key right there, familiar shape. So that's 61, and now 62. Let me get to that one, which is also by Jim Moore, but adding now Harold Krivoy. And they note this was a 2-day eruption at the end of 62, December 62. 6 fissures with a right offset pattern, just like the other one. 2 miles from Kīlauea Crater east to the west slope of Kananui Hmau. A very small volume of lava erupted, much of it ponded in Kīlauea and drained back into the fissure on the floor of the crater. They show uplift near the eruption site of over 2.5 feet, along with collapse of the summit at the same time. So same summit deflation and rift zone inflation as we see of this pattern. And this paper, by this point in time, they're starting to really see this reestablishment of the east rift zone of Kilauea, which at the time was not really a well understood thing. And so a lot of this paper at the end goes into what is the east rift? How is magma moving there? We're seeing this distinct pattern of summit deflation feeding east rift inflation, summit collapse. So these must be connected. It must be all one system. So that was when they were really figuring it out. And so they really go into that a lot in this paper too, which we will not as much, but I will just show you what their diagrams look like. So our field area, and within the east rift zone here, we have marked by these circled numbers the eruption sites of the 62 eruption in December. So 1 by Kīlauea Crater, 2 on the west side of Kananui Hmau, 3 westward of it towards Alai, 4 steps to the north as it goes to the west, 5 and 6 in between them right there. Right, and Maunaulu now exists right in here in this similar area that erupted in late 62. So there it is, small pads of lava, all very near these lines of the cracks right there. You don't see a whole lot. If you're curious about the long-term pattern, this is the ground tilt at the summit. So 1960 eruption, couple hole, major deflation, we'll recover, refill with magma. Here's a 61 eruption we just talked about. Even though we had 3 summit eruptions, there, and there, they don't cause any change in the tilt until the flank eruption happens. Rebuild of 62, small drop in 62, still rebuilding. And this is the progression of how in the 60s, the east rift zone was reoccupied. So similar patterns of uplift at the rift, collapse at the summit, similar to the satellite radar images we're showing you guys today. And let's see here, the pulses of eruptions with volumes once again. So December 6, 7, 8, 9, right there. In this case, the first pulse had the most volume, second and third back to back, the next, and then a couple of after small pulses that came after that main first onset, with this final one, number 6, actually reaching a decent volume here at the end, the last hurrah of it on the second day. They're noting same thing, deflation of the summit, ground cracking at the rift, tremor, earthquakes, so intrusion happening as well, feeding this eruption. So that's the 62. I can come further down here and note that here's where they start talking about how they're seeing an upper east rift and upper part of the middle east rift. They have the Kauai faults, and they seem to be dipping to the north when we have the other faults dipping to the south, the Helena also as well. How does this all work? How do you get cinder cones or craters or fissures erupting? And this is kind of where this beginning idea of how the rift zone and south flank interact actually is began being documented here. So really fascinating. That's the 62 eruption. There are no pictures in this paper, unfortunately. So you can imagine they probably look like these other ones that we had from 61 as well, where we have these fissures out in the middle of the forest, burning trees and leaving lava trees and those sorts of things. So that's the volcano awareness presentation for today. We do have a couple of other items to step through. I was looking to see if the USGS had actually dropped a...
Not yet.
So
Yeah.
we'll have to skip volcano watch this week, but we will step in to finish off with monitoring Mauna Loa. So Mauna Loa over the last week, here's the tilt. This deviation in the blue line is likely the effect of the hurricane. I don't think there was quite as much rainfall up on Mauna Loa, but it seems like there was some effect somehow or another up there, as you see here in this week-long plot. Not any corresponding earthquakes really up there to speak of. Earthquakes have been fairly low, and in a month-long view, there's that little wiggle, perhaps corresponding to the hurricane. So there's a last month, continuing inflation in the shallow part of the volcano as it's refilling with magma slowly, uneventfully, without a whole lot of fanfare, not a whole lot of earthquakes or anything really unusual happening, but it is just recharging there fairly low key. So per day, the earthquakes, many days have none. At most, we're having 5 or 6. So over the last year, earthquakes per week were quite low, less than 30 per week. And per month, we're down maybe less than 50 per month or something like that down in here. So very, very modest earthquake numbers. You really have to plot all the ones for the last year to even get some kind of density of events that you can examine, some kind of pattern there. So very slow on Mauna Loa, but still recharging is the pattern there. And yeah, that's where we'll wrap it then, and see what other questions there might be.
I do not have any questions for you lined up right now. Yeah, that I think we got it all. Good job. It is interesting the similarities again, just between the activity then and the activity now in the same rough area. So I'm enjoying this whole flashback to the 60s and revisiting some of these sites that are now seeing activity once again.
Yeah, so now we've done number 1, 2, 3, and 7. So we'll keep going as we can, as activity allows us.
Yeah. All right. Yeah. So no questions right now. And we just take this opportunity to thank everybody for stopping by. I know we rely really on viewers like you. I've said it before, to get this information out there. The likes and subscriptions, the shares, all of it really does help. And yeah, we need to talk about bringing that betting back about when is the thing, because we were doing that for a little while, and then we had the eruption all of a sudden, and we hadn't redone it. And I feel like it would fool a lot of people, this one. Like every intrusion, like, oh, it's about to erupt, it's about to erupt. Oh, never mind. Oh, it's about to erupt, it's about to erupt. Oh, never mind.
Yeah, it's been really hard to really nail down, hasn't it? It's become a little bit more unpredictable, a little more variance maybe. So that's why it's harder to set the line, really, right?
Mm-hmm.
To know what's even reasonable nowadays. So,
yeah, true. All right. Well, yeah, I think that does it for us. Our normal time is 5 p.m. Hawaii Standard Time. We do this stream weekly, and unless something happens, say it erupts, then we will go live and do something special. But if you want to catch us, 5 p.m. is the place right here on HVERI on YouTube and the Hawaii Tracker Facebook group, as well as our new Instagram, which please check that out, which is on HVERI as well.
Mahalo, Dane. Mahalo to Lou in the back end. Mahalo to Dano and Kerry, our ASL interpreters. Appreciate you guys always. We'll have to practice our signing once again. I think we're out of practice, but
yeah, you should have seen what happened when you guys left. We had Lou fill in, and it just didn't go well. No kidding.
So yeah, appreciate you guys. I appreciate all you guys watching us and following and sharing good information with your neighbors and friends. We do this to inform our community because we want to be better prepared whenever the next disaster does occur. It will happen eventually. But in the meantime, before then, we can educate ourselves and understand how the volcano works and how other disaster preparedness works. And that's where we're coming from with our update today. So from our nonprofit, HVERI, Hawaiian Volcano Education and Resilience Institute, it's Dane DuPont, Daniel and Kerry, I'm geologist Philip Ong. Aloha, everyone.